On Developer Voices this week, I'm joined by José Valim, the creator of Elixir, and we're going to take a look at the evolution of the language, from what he wanted Elixir to be in the early days to what's happening right now. And it begins with a classic scratch your own itch story. He just wanted a language that worked on the Beam, the same distributed platform as Erlang, but with a few extra features that he was missing from the likes of Ruby and Clojure. And we talk extensively about which features they were and how they gradually made Elixir into the language he wanted to use. A language that has been very well received. It's been used in some seriously large real world services. You can find traces of Elixir in companies from Spotify to Pepsi. For a long time, it was the backbone of WhatsApp. It's currently a very popular way to build websites with the Phoenix framework. Elixir has been a success. But all that kind of condenses a long journey, a journey of about 12 years, and you have to wonder, is José still as enthusiastic about developing Elixir as he was back in 2012? And talking to him, I got the sense there was a slight lull in those middle years as the language stabilized, as it could be considered done. But if there was a lull, it's abundantly clear that right now he's as enthusiastic as he's ever been, as he's working on bringing a gradual type system into Elixir. Opt-in gradual typing added to an established, well-received, dynamically typed language. How's that going to go? I try not to take sides in the type system wars, but I do think that static typing is one of those features that gets more and more valuable the larger and older and more mature the code base gets. So the thing that's got José fired up about Elixir development might well take its user base to a new level too. Either way, it's a fascinating technical journey to hear about, so let's hear how it's done. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is José Valim. I'm joined today by José Valim. How are you doing?
I'm doing great. Thanks for having me.
Oh, thanks for being here. You are right. You've been a language designer for 10 years, which kind of puts you younger than Donald Knuth, but more of an elder statesman than some. You're the kind of middle-aged language designer.
Yeah. I'm wondering which kind of midlife crisis come with this particular package.
You'll have to let us know in hindsight. But I think so. We should go back 10 years, 12 years. 2012, you created Elixir. Right. And I've always had the impression from the outside that the primary motivation was love Erlang, don't like the syntax, let's put a normal syntax on it. Is that true, close to fair?
Halfway there. A lot of people, I think a lot of people think about the syntax. It's the first thing that comes to their mind because Elixir and Erlang syntax, they are so different, right? Mm-hmm. And Erlang syntax is foreign because it comes from Prolog. It comes from that particular tree, the descendant tree.
Yeah.
And Elixir is closer to other dynamic languages, like mainly Ruby, but also some from Python as well. And I think like syntax is the first thing that pops up to a lot of people's head. But for me, I can't remember if I don't think syntax was a big concern at the point because there are things that I really like about Erlang syntax because it is very concise. It's also noisy in the sense it uses a lot of punctuation characters, which is common for Prolog and many functional programming languages. But it's extremely concise, and there are things that I feel Erlang in its syntax they do more elegantly than Elixir.
Do you have an example?
So I like, for example, if you take function definitions, like in Elixir and Erlang, you can have a function can have multiple clauses, and in Erlang, I feel like, for example, if you have to write several clauses side by side, Erlang is going to be much more concise than the Elixir one. And I actually prefer Erlang one, right?
Okay.
And then, yeah, it's something that when you see side by side, you'll be like, oh, yeah, the Erlang one, there is like less, there are definitely, you have to type less, let's say, right? It's more concise. And and so for me, it was more like it's love Erlang, and it
Mm.
was more about there were some features that I felt was missing as part of Erlang, but not
Okay.
necessarily as part of, there were some that are part of the language. Um, and we can talk about them. So like everything being UTF-8 encoded by default. When I started doing Erlang, Erlang was uh, one particular kind of Latin, which I believe I could
Oh.
not even like write my name correctly without adding special notations because I have
Yeah.
a with accent, right?
Yeah. Yeah. Yeah.
So there were some things at the syntax level, but it was mostly about like as a abstraction level, right? And there were two things in particular. So one was metaprogramming, and the other
Right.
one was some sort forms of polymorphism. And the thing was that so Elixir actually, like if you go back to the repository, it started in 2011 because I was mostly playing with ideas. So like the first version of Elixir was actually object oriented,
Okay.
and because I was coming from a Ruby background mainly, right? And I was like, well, I'm missing those things. And then I was like, well, I think what I'm missing is objects. And it turned out, spoiler alert, it was not objects. Um,
Okay.
but I felt like this is what I'm missing.
Yeah.
So, and then I tried explored a couple different things, and then like a year later, I landed on the design. But one of the things in this process was that, like, look, I want metaprogramming, and there are several ways of doing metaprogramming. And throughout this journey, I was like, look, I got to I got to the conclusion that I want a Lisp style metaprogramming, and the
Okay.
idea is that you can treat code as data. So macros mean different things in different programming languages, but in Lisp and in Elixir, a macro is I can actually receive when you call a macro, the macro can actually access the representation of the code. The code is represented as data, and then the macro can go and manipulate that code as data. And I felt that was really good for Elixir because Elixir runs on the Erlang virtual machine, and Erlang virtual machine we have the code is compiled, right? So I think this kind of pre-processing happening during compilation through macros, it's a really nice fit to the Erlang virtual machine and how it compiles and runs code.
Right.
So I landed there, like, okay, I want a metaprogramming and I want Lisp style metaprogramming. And then there is the obvious question: why not Lisp then, right? Like, why not
Yeah.
create a Lisp that runs on the Erlang virtual machine? And when I started Elixir, I am for sure there were two Lisps, but potentially three. There was like there was LFE, which is Lisp flavored Erlang, and it's maintained by one of the
Okay. Yeah.
creators of Erlang.
So you mean
And
3 Lisps that were available for Erlang's virtual machine?
yes, at the
Yeah.
time,
Okay.
yes.
Yeah.
And there was one called Joxa. And later on, I know like there is a closure, which is a closure running on the Erlang virtual machine. So like people have been trying Lisps on the Erlang virtual machine, right?
Hmm.
And then I was like, look, I'm not going to do another Lisp. Okay. Take the pros, take the cons. That's a whole separate discussion. Right. But like,
Yeah.
look, I don't want to have a Lisp. I want to try something different.
Yeah.
So my idea, which I thought was novel, okay,
Okay.
my idea was, look, I'm going to define like some basic syntax, and I'm going to add like some convenience construct. So for example, in Lisp, you don't have operators, right? If you want to add two numbers, you do plus 3 and 5, right? So you put the plus first, then the 3 and the 5. Everything is written in the same notation in a Lisp. But
Yeah,
I
it's
was
all
like,
prefix-driven syntax, right?
yes. So I was like, well, so imagine that I have like this prefix notation, but I'm going to allow some affordances. Like I'm going to have operators. I'm going to have this and that. So I started with this. I started with a basic syntax and added some affordances on top of that. And
Right.
while I was doing that, I was like, okay, I don't want it to look like is not going to be a Lisp, so what is going to look like. And because I had a lot of experience with Ruby, I ended up making like some Ruby like decisions in that part. But I also feel like it's kind of over, like overstated. Like if you get Elixir and you replace so we use do and end, we use words
Yeah.
to delimit blocks, right? And one of the reasons I wanted to do that is exactly because I was coming from Erlang, where it used a lot of punctuation characters. So as I
Mm.
said, it's noisy. Like the ratio of like punctuation to words, it's kind of high. And
Yeah, it's a
then
little bit
I'm
squiggly.
Yes, and
Yeah.
it's common to functional programming languages. And again, I'm not saying this like this is bad. I'm just like saying that's how it is, right?
Yeah.
Some
Yeah.
people like it, some people they don't like it. And I was like, okay, so what I'm trying to do is that I'm going to try to balance and use do end blocks to delimit blocks of code. And that's pretty much it. Like I think if you get Elixir
Okay.
and you replace all the do end blocks for like curly brackets, it's going to be like is not going to feel much like Ruby anymore. So I think like that's the part that makes it look the most. And optional parentheses, which is another discussion. Anyway, I'm going off like so. But to summarize, it was not really about the syntax. It was more like, look, I want these particular features. I want meta programming. I want polymorphism. And then in order to implement them, I had to make a bunch of decisions, right? And I was like, oh, okay, I don't want a list. So how do I want to look like?
Yeah,
And
yeah.
those decisions ended up having a different syntax. But the syntax was not the syntax was not the mean. It was an end, right? Like in order to
Right, yeah,
get
yeah.
there, I ended up doing that. And the thing that I said that I thought I was coming up with a novel idea, later I learned. So in Elixir we have like this syntax that has a direct translation to AST, to its like natural representation. And then I
Yeah.
learned that in the paper by John McCarthy that introduces Lisp, the paper that introduced Lisp, it actually has the same idea. So in the
Oh.
paper, he's like, look, we are going to have Lisp, and there it was called S Lisp, so for symbolic Lisp. And then McCarthy says, look, but this representation, the Lisp that we use, like that most people understand as Lisp today, he was like, this representation is too low level. We need to have a higher level representation
Yeah.
that is going to translate to that one. And I believe it was called MLisp. So
Yeah,
it's
yeah.
funny that later I was like, I thought it was not. It's like, nope, it's there since the beginning, since Lisp
Yeah, yeah,
exists.
yeah. This rings a vague bell. I remember reading somewhere that Lisp was always supposed to have a different surface syntax, but never really got round to it.
Yeah, I believe that's
Yeah, yeah.
exactly it. Everybody just went with the S Lisp. Nobody really went with the M Lisp.
Yeah. So how does that change metaprogramming? I mean, Lisp style metaprogramming, because if you've got a Lisp, there is almost no difference between the code you write and the data structure you get when you're doing metaprogramming. Right? They're almost identical, but you must have a translation.
Yeah, so you kind of learn that, look, this code is going to be represented as this code. Like, so this code is going to become this particular data structure. So there is a translation layer, which, to be honest, it's how most programming languages work. Like most programming languages, they have the syntax, right? And the syntax becomes a representation. The challenge in Elixir was exactly, and Erlang works like that. For example, it has the syntax and then you have the representation. So the challenge we had for Elixir is, what is the minimum language that we need to have, so the syntax translation is straightforward. So we are not asking developers to learn like, 20 different translation rules. So
Right.
that
Yeah,
was
yeah.
the trade-off. Like we need to keep the the surface as small as we can possibly can.
Right. Yeah.
As we
So
Yeah.
presumably one of those rules is if the syntax is infix with operators, it's going to be changed to a tree, right? Something like that.
Yes, exactly. So, like an operator and a function call, even though like syntactically they are different because the operator is in the mirror, in the middle, the function call has the arguments. In the ST, they are represented the same way. they are all considered a call. So for Elixir, for example, a operator is a function call as any other. While other programming languages, they actually have a distinction between what is an operator and what is a function call, and those are two different things.
Mm.
In Elixir, it's the same. It translates to the same AST. It's just syntactically, it's something else.
Yeah, yeah, that makes sense to me. It's like that kind of distinction only exists at the syntax level. By the time you get into what's it actually trying to achieve, that distinction is gone, right?
Yeah, and it leads to very interesting things because uh, in Elixir, the syntax and the semantics, they are, which is exactly what you have in Lisp, the syntax and the semantics, they are somewhat divorced from each other. It's not 100% divorced. Of course, they are, you need to tie things together at some level, but they are divorced, and then you have to, and that brings like great features. So for example, one of the things that I like to say, like today you can get, there's a library called NX, numerical elixir, that gets elixir and compiles it to run on the GPU. And it's a library, it didn't require any language changes, right? It's
Ah,
just a library implemented using Elixir existing features. And but on the other hand, it leads to some complications. For example, well, I find, imagine that in my parser I find something about like an invalid syntax. Now, there are examples I can't recall, but let's imagine that I find something like it's an invalid syntax,
okay.
and then I want to tell the user, look, maybe you wanted to do this and this and that, but because the syntax and semantics, they are divorced from each other, I cannot in the syntax assume that the user wants to do something in particular, right? I have to assume that, look, this is syntax. The user can get this and compile to the GPU. The user can get this and compile to a SQL query. So
Yeah.
all I can assume are things about the syntax and not much more.
Right. So this must play in at the same time to polymorphism, because you've got, especially in a dynamically typed language, right? You end up, you're writing a macro. I don't know if you use that term macros for these,
Yeah,
but
we do.
yeah, okay.
Yeah.
So you're writing a macro, you get some arbitrary syntax tree that you have to process, and you have to say, well, okay, I'm dispatching on, if this is a function, I'm going to do this kind of thing. It becomes inherently polymorphic because you've got this syntax tree which is carrying lots of different things that you need to walk down. So how does elixir flavored polymorphism look?
Yeah, exactly that. That's an excellent question. So there are two things I want to say here. So first one is that what I'm going to say, and a lot of Elixir features, they really come from Erlang. So, and Erlang, yes, it's a dynamic programming language, as is Elixir, but they are much more assertive than what we usually consider to be dynamic programming languages. Because when you take up like general dynamic programming languages like Ruby, Python, JavaScript, right? They're
Mm.
usually object oriented, or in general, we can say like you are, for example, you're calling things in objects, right? Like, so you have an object, you say true number or true string, right? And you don't necessarily know what is that thing. We say like things like duck type, and like, oh, I actually don't care what is this object as long as it implements that true string function, and that's the, or method, and that's the only
Yeah.
thing you care about. In Elixir, we don't have objects, nor in Erlang, and we have some predefined like data types, and we are often just pattern matching on them. So, for example, like Elixir represents its main AST node. It represents it as a tuple with three elements: the function name, the metadata, and the arguments to that function. So sorry, a
Oh,
function
okay.
call. A function call. We
Yep.
represent as a tuple with three elements. And then you can go and pattern match on this. You can say, look, I'm expecting you write literally the syntax for tuples, and you pattern match on each exact element. And we have, which is very similar to, for functional programmers, when you think like abstract data types, when you create those data types that you
Yeah, yeah,
define
yeah.
as like, and then you have to match on them exactly. That's pretty much how it works in Erlang and Elixir, except that you match on any existing shape there is. Um, so you can match on tuples, you can match on lists, you can match on our dictionaries. There's a pattern matching syntax for pretty much everything, and that came from Erlang. So we have this polymorphism, right? But the issue with this polymorphism when I was starting using Erlang is that similar to other functional programming languages. So I'll take, well, we can pick any other, can pick other functional programming languages, and I'm going to talk about how we solve this problem. So that's definitely a form of polymorphism where we're like, look, this function accepts a parameter of different types, and then you can pattern match on those types. Like if I was using like a statically typed functional programming language, what I would do is that I would define a type for the AST, and then for each node in the AST, I would describe all the different nodes individually, right?
Yeah.
And I would be able to do that. So I will define a general type and define like each possible node as part of that type, right? The problem with this code is what it doesn't happen for AST, right? But imagine that, well, what if you want to add a new node representation to that type thing,
Yeah.
right? It's not really possible, right? So but with AST is weird. If you're going to add a new node, a new AST node, you end up adding a new AST node to the language. But think about, for example, I like to use JSON as encoding because that's a very common use case. Imagine that you are building a web application and you have your business, you have your like your domain types, like, imagine it's a e-commerce. You're going to have a type for representing a cart, a type for representing like the shopping items, everything that you bought, you model
Yeah.
in your business domain, right? And now imagine that in order to expose that through an API, you have to convert all those things to JSON. Okay. And in
Right.
order to do that, you would most likely create a function called toJSON in
Yeah.
your application that receives all the possible types, right, that your application knows about, right? It's going to go. So it's exactly the polymorphism that we're talking about. It's like it's parametric polymorphism because the types, they are coming as the possible arguments there. So you may need to have some wrap. May need to wrap things around, maybe not, but you have to define like this huge type that receives this huge function to JSON that receives all the types on your system. So you receive those things as parameters and convert them. That's one of the ways that you can do it, right?
Right. Yeah.
And every time there is a new type, somebody needs to go, if I'm another member of my team, they are adding a new type, they have to go and change that to JSON, right?
Yeah.
Which for an application, it works fine. But for an ecosystem, it's kind of tricky because it means now, imagine that I'm working on this application and I need to use a library that introduces like a money type, right? Because you don't want to model money with float, right? You want to have a specific type that models money, currency, this kind of
Yeah.
stuff,
Yeah.
right? But now that library, when I bring that into my application, I have to handle that type also in that huge to JSON function, right? I
Yeah.
have
Yeah.
to handle it there. But imagine that I also imagine my standard library doesn't have a set, right? Doesn't have a set data type. So I bring another library and I may have now that money type inside the set library. And now I have to go like, so it gets
Yeah.
to some point where if you want to compose, if you want to say, look, I'm just going to bring this set and I'm going to provide a way for you to handle JSON and allow everybody to compose those things together. And you just render JSON. That's the polymorphism that I was missing, right?
Yeah.
So in order to recap, Erlang always had, it's dynamic, but it always had this kind of like parametric polymorphism, but it was not extensible. The only way for me to teach like a function how to handle my data type would be like by forking that code or changing that code. I
Right.
had to
Yeah.
go there and change it. And that limits the creation of contracts because I cannot have a library that says, look, give me any data type that is convertible to JSON and I'm going to work, because you don't have this extensible mechanism. You don't have a mechanism where everybody can say, oh, I'm going to implement this. You cannot define those contracts. So we had parametric polymorphism, but it's there. It's in a single place. You can add as many clauses as you want to that thing, but you
Yeah.
have to change. And what we add to the feature that we added to Elixir, it's something that it's very popular today because like it's equivalent to Go interfaces, it's equivalent to type classes in Haskell,
Right. Yeah.
it's equivalent to protocols in Clojure. Is something that is an extensible polymorphism. So I can say things, look, give me any data structure that can do this and I'll be fine. I'll be able to figure out the rest. And we use this like kind of everywhere. So for example, even simple things like if your programming language has a REPL, has a terminal, right?
Mm.
How do you know how to convert that a data structure to print in the terminal, right? Because if you have a data structure and you want to print in the terminal, you can leave everything hard coded, but it's a great use case for a protocol. You can say, oh, you had this data structure. You tell me how you want to represent it, right? And then we can provide higher level representations of internal data types. And so that's yeah, so we've gone through both of them. Those are the two things that I really wanted to add in Elixir. It was meta programming and this sort of extensible polymorphism. They are multiple different implementations, but in Elixir they are called protocols.
Right.
And they bring this sort of polymorphism where I can define data contracts and say, look, you can give me anything as long as you implement this, I'll be fine.
Okay, so someone can write a protocol like show on the terminal, and the person writing the data structure can implement it, or the person writing the protocol can implement it.
Yes,
Yeah.
yes.
And you're not tied to owning one or other code. You're not tied to owning a specific side of the relationship.
Exactly,
Yeah,
exactly.
yeah.
Also
Okay.
like trait in Rust, right? In Rust.
Yeah.
And just to wrap this up, it goes back to the beginning when I was thinking like, oh, when I was starting to use Erlang and I felt some things were missing. And I was like, I think that I was missing objects. I was not really missing objects. I was really missing this particular form of polymorphism. That's what I was missing.
Yeah. And
Um,
you have that one, like, I think I'm right in saying, like, in Java, you have interfaces, but the problem is that it's the object that has to implement it. Right? You have to have access to the object source code to use a new interface.
I'm honestly not sure with 100%. But I mean, I think you should be able to implement an interface for another object. But the issue is, I mean, this issue also happens in Elixir, is that if you are implementing an interface for an object that you don't own, that object needs to expose the functionality necessary for you to implement that interface, right? Because otherwise you cannot implement it. You see what I mean?
Yeah, and I think in Java you always end up with, if you don't have access to the object, you have to create a wrapper object that just exists to implement the
Mm,
interface that you own.
I
You own the
see.
wrapper so that you can add the interface. But you're saying a protocol-like thing splits that up, so it doesn't matter which side you own.
Yes,
Yeah.
exactly.
Okay.
Exactly.
That
Yeah,
sounds.
but you still need to rely on the data structure or the module that works with the data structure providing enough information for you to implement the interface, right? Because you should not access the internals of the data type. So there is still like some boundary, but there is no language limitation. Is a software design limitation.
Right. Yeah. So I know that there was some influence on Elixir from Clojure. So I'm going to ask this because Clojure has this thing called multi-methods, right? Where
Yes.
you can do polymorphic dispatch, but you can also include logic in it. Like, if the first argument is less than 5, then I am the method that you're going to run. Otherwise, look elsewhere. Do you have that?
Yeah, so yes and no. So the way that like I was saying, like that to JSON function, the way
Yeah.
it works pretty similar to how a multi-method works in Clojure, but it's exactly that it's not extensible, right? So you define it once. So we have like you can create dispatching rules like, look, if this argument is this and the other one is that, we call them patterns and guards. So you can write code like that, but it's not extensible. And I believe Clojure multi-methods, they are extensible. I think I can add new rules to a multi-method anytime. And
Yeah,
that
I think
we
you
don't
don't need
have.
to own them. You don't need to own the definition or the object. You can be a third party. Just
Yeah.
almost feels almost a little bit like monkey patching.
Yeah,
Yeah.
it's yeah, but without there is the big thing which is like namespace clashing, and I that monkey patch can make it like very common, that I don't feel multi-method has. There is another language worth saying here that has this that we are describing, which is Julia. I believe Julia, you kind of like everything is a multi-method, in the sense that you can, if you have a function, you can kind of define like new clauses that dispatches on any type at any moment. um so that's also very interesting. And yeah, and closure was one of the influences. The fact that we call our protocol, the fact that we call our polymorphism protocols, is exactly because of closure, because our design is the closest to closure. And multi-methods, they are more general than
Right.
protocols, right? So for me, it's like, ideally I would prefer multi-methods, like in an ideal world, right? I would
Okay.
prefer multi-methods because they are more general, so I will be able to express more things with them. And I think there are programming languages that really do interesting things with them, like Julia. I don't know if this is still accurate, but I think at the time, when I was talking to Clojure developers, they were saying that multi-methods, they are rarely used. That for some reason protocols, they were preferred. And but the biggest thing was really, so that was mostly, when I heard that, was mostly for peace of mind, because the biggest thing is that I don't think I could implement multi-methods efficiently in the Erlang virtual machine.
Oh, right.
Maybe I could, but it's it's not easy. It's not easy. Maybe today, like with 10 years, 12 years of like experience in the back,
Yeah.
in my back, like I can go back and like, oh, maybe I can try to design multi methods now. But there is, I don't even know if closure solves it, because that's the other thing. Like you can have something that is, that does one thing and does not do a lot, but you can have something that is really flexible, and then people can use a lot of things, and then it that may lead to code that is harder to understand or hard to maintain. So like, how do I ensure that a multi-method is not going to clobber the other one, right? So
Yeah,
if
yeah, yeah.
anybody can register a multi-method at any moment, how do I ensure that they're not going to be conflicts? And so like solving those problems, and then like, well, if you have, and it depends in which way you allow you to guard those multi methods, because if I allow people to write like arbitrary expressions, or even like comparison operators, if x is more than 5, right?
Yeah.
How I'm going to implement the code that is going to say, look, you are overriding something that the user wrote, and uh, and that may actually, and that's going to lead to issues that are going to be very hard to debug, because you have library C, you know, defining something that library B was expecting to work, and now there is one library very far away that is not working as you expect.
Yeah, yeah.
So I think like those are trade-offs, and I think like having a more general mechanism can be a powerful feature to have. But I think in order to add something like that, I would also like to have like some balance, some checks in there to make sure that users are not going to make obvious mistakes or hard to debug mistakes.
Yeah, yeah, I
And
totally get this.
yeah, and that's hard work. It's actually like hard work to guarantee those
Yeah.
properties.
Yeah, you open up all those features and then you have to design useful and usable ways to close them back down again, right?
Yeah.
This is always something that interests me about language designers. Like, where do you sit on that power spectrum? Because it's been a while since I've been a professional closure programmer, but multi methods were used sparingly in my time because they're really powerful. You can do anything with them, but they also run the risk of the actual behavior you get is magic because you didn't know there was another definition over there. Right? And it's like pinning down what's your sweet spot for power versus usability.
Exactly.
Yeah, yeah.
And yeah, and I don't think there is it, like I said joking at the beginning about like midlife crisis. And I think for me that's exactly that's like a hard part of it, because there is no answer. And then sometimes I'll be like, well, what if I did this thing differently?
Mm.
And then it opens up, like it closes the door on so many other things that I actually enjoy. And then I will be like, oh, I wouldn't make the choice. Like still, right? I would still keep things as is. I think like the Lisp style metaprogramming is a really good example because when you have like Lisp style metaprogramming, we're talking about syntax and semantics being divorced from each other. And then there are places like if you are implementing like a language server, for example, it
Yeah.
actually when I see a plus, right, in 99.9% of Elixir code, the plus means the plus, but somebody can go and actually replace that plus to mean something else,
Right.
and that makes those tools harder. And I mean, like, we're talking about like balance. So what I did in Elixir is that, look, you can replace plus, but in Elixir everything is lexical. If you want to replace what plus means, you need to have something in the code that says, look, I am replacing plus, right? So I can never do things globally. I cannot change the meaning of plus in Elixir globally. There is always going to be a line in there saying, because plus in Elixir is a function, I can say, look, I don't want to import plus from kernel, which is where everything is imported by default.
Right. Yeah.
So I
Yeah.
can say, look, I don't want the plus from kernel. I want to bring this other plus. So it's there in the code, but now it means that a language server needs to go through the code, process these directives saying, I want you to remove this, I want to add this,
Right.
and
Yeah.
it's more work, right? And then I could say, well, I could I could like not have those features, and then it would require less work on the language server side. But like this feature, the plus, it's a very small feature. It's a plus operator, right?
Yeah.
It's what allows us to write Elixir code that runs on the GPU. I can write an Elixir code that is using plus,
Yeah. Yeah.
division, multiplication, because that thing replaces the plus. There's explicit call saying, look, I wanted to replace the numerical Elixir operations by the GPU Elixir operations. It's
Yeah.
there
Yeah. Yeah.
explicit. And
Yeah.
it replaces that, right? Which for me, it's an amazing feature. It's a very exciting feature to have. And then I'm like, yeah, like this is a really tough trade-off. So yeah, so for me, like this checks and balances, like, look, I want to have this thing be be expressive as a programming language, but I don't want to allow somebody to change the meaning, which would be monkey patching, right? Like I
Yeah.
load
Yeah.
some code, and just by loading that code or by adding a dependency, that thing would immediately change what plus means. That I
Yeah.
don't want, right?
Yeah.
But if I say, look, I want to change, I should be able to do that.
Yeah, yeah. It's funny how, like, once you open the door to metaprogramming, you've reignited that global variable versus local variable things. In the global variable, what does plus mean?
Yeah, yeah, and that's why for us it's like, look, all the macros. So like for example, you don't even have to, in order for you to call a macro, you have to require it. I cannot call a macro without saying. So in Elixir, like I believe Clojure is like that. Clojure, Ruby, well, but in Elixir, like when I'm going to call another module, many programming languages are like that. When I'm going to call another module, I don't need to explicitly require it. It's not required for me to have an import or something like that. Many
Hmm.
languages require you to do that, right? So it's convenient. I don't have to, because sometimes they're going to work on projects that have explicit imports. The first 20 lines of every file is like
Yeah, yeah,
all the imports that you have to do.
yeah,
In Elixir, you don't have to do that. But we kept this for macros because, look, I don't want, like, if you're going to call a macro, you have to say, like, so we have like all those signals of like, look, I am bringing something that is going to potentially change the code
yeah, yeah,
in
yeah. If you're
in
going to
in
change the
ways.
rules of the game, you have to be explicit
Yes.
about it. Yeah,
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 Rust does something similar where I think all macros they end with a exclamation mark
yeah,
as well. Just like being there, like, look, things can happen different than you expect. So it's always it's always explicit, and yeah, the option is there, but you have to say, look, I want this.
Yeah, yeah. I want to get into the specifics of numeric elixir in a moment, but there's one more core topic which we've touched on, which relates to this whole "what do we do at compile time" question, which is like optimization, compiling. For starters, does Elixir compile to Erlang, or does it compile to the same bytecode that Erlang compiles to?
So Elixir, by design, we compile to we get the Elixir AST and we convert that to the Erlang AST. So
Oh, okay.
so most compilers, they have multiple representations and multiple passes, right? So it's like
Yeah,
it starts with the high level AST, and then it's at some point transforms to something else that is better to do some optimizations,
yeah.
and then at the end you have bytecode. um I think in Erlang you would have, if you want to target the Erlang virtual machine, you realistically have three options: the Erlang AST, something that they call the core Erlang AST, and the bytecode. And I chose to target, and you could actually compile to Erlang source. That's what Gleam does, I believe. They actually compile to a textual Erlang file
Oh, okay, yeah.
and not AST. But
Didn't
that
know that.
has like some very big limitations, like your lines are going to be off in stack traces, right? So when you get an exception in Gleam, I believe, like the stack traces, they do not match your actual code,
I haven't checked that.
which is something that yeah, like the JavaScript community, they had to solve those issues. That's why you have things like source maps and
Yeah,
so
yeah,
on.
yeah.
Yeah, so I think those are the four options, and we chose the Erlang abstract format because it allows us to have like proper stack traces and everything, proper error messages, but still share as much as possible, uh, as much as possible tooling as Erlang. And the
Yeah.
reason we did that at the beginning was because there were like, so Erlang has a tool called Cover, which is for test coverage,
Okay.
and the test coverage maybe changed today, but the test coverage, at least back then, it would analyze the Erlang AST and add annotations for test coverage. And and if I didn't target the Erlang AST, I would have to implement my own cover version.
Right. Yeah,
um,
yeah.
there's also a tool called Dialyzer, which is like it's a discrepancy analyzer. It's kind of a type system, not really, but it's aims to find bugs in your Erlang and Elixir code.
Right.
And Dialyzer as well, I believe at the beginning it required the Erlang abstract format. So in order to maximize like the tool, what we could use from Erlang, we chose the Erlang abstract format. But later on, with time, I wanted to have the option of like, well, maybe I want to compile to core Erlang in the future, and then I would be able to do things that I cannot do today. So I would get like a little bit more expressive power. So with time, I actually made a bunch of improvements. I submitted a bunch of improvements to the Erlang compiler tooling.
Oh.
So it allows programming languages to say, like, look, I'm going to keep my own representation of things, and if you want something else, I'm going to give you that something else. So I came up with a contract between programming languages and tools, so we have the flexibility to choose. But we never really ended up like making the change. We still target Erlang abstract format, but we have done work to be able to say, oh, if we want to go lower level in the future, we can as well.
Okay. I suppose one huge advantage to that is just like you were saying with Elixir macros, right? If you can turn, if you know how, if you've got an intuition for how the syntax of Elixir turns into an AST, you can write macros. I guess you develop the same intuition of here's the Erlang source code I want to ape. I know what AST that will represent, so I know how to compile it.
Yes, the translation layer, it's like it's really straightforward
Mm.
between one and the other. Honestly, the only tricky thing in the whole translation layer is how it's the difference between how Erlang and Elixir they do variables. Like that's potentially like the biggest difference between the languages. So in Erlang, the variables they are you can only assign them once, right? So if you do x equals 1, you cannot do x equals 2 later, right?
Right.
And that's good. There's a long blog post I wrote like comparing the variables and the pros and the cons. Elixir does allow rebinding, and one of the issue why we actually allow rebinding is because of macros, but it's a separate conversation. But you can think that a macro may want to pass some information around using the same variable, so you need to rebind it, and you cannot generate a new name every time because then you have to find a place to track the new name. There are some complexities there, but it was one of the reasons. But also because I saw that in a lot of places in Erlang code, because again, like everything is immutable, so you are transforming everything, and sometimes you are transforming the things, but it's still ultimately the same. So in Erlang code, you would have things like uh, post 0, post 1, post 2, post 3,
Oh,
because
yeah.
you have to version the variables because uh, you cannot reassign them.
Yeah.
So that's a very big difference between the languages, between the two. And the other one is that the mm, I don't like the variable scoping in Erlang. In Erlang, if you do if I have like a case or a if, and if I change a variable inside that scope, that variable may actually be available outside of that scope as
Oh,
long as
okay.
all clauses assign the same variable. If not all clauses assign the same variable, then you get a compilation error. But so there's this thing like I can be on the inner scope, and changes to that scope may affect the parent one, and Elixir doesn't have that. So in Elixir, if you are inside a conditional, any change in the variable that you want to make inside that conditional, you need to return as a result of that conditional. So
Right.
like
Yeah. Yeah.
if, case, like switch statements, all those things in Elixir, they define new scopes. And I think this is, and not many languages do this, by the way, like very, very few of them. Functional programming languages, they tend to do that. And I think it's a great feature because it makes refactoring so easy. If I have like some piece of code, right? And if I have a conditional and I want to move parts of the conditional to a separate code, I can just get that code and move it and pass the
Yeah.
same
Yeah.
arguments in. If I have a conditional that is setting a variable that is changing the outside scope, right? It's changing the
Yeah. Yeah.
parent
Yeah.
scope. Now you have to come up with now you're like, oh, but this variable was here. Now I have to pass it back. You
Yeah.
have to do all the work. And in Elixir, it's like, oh, you want to move code around. It's always inputs and outputs. That's the only thing you worry about. There is
Yeah. Yeah.
no scope changes.
You kind of want
So
conditionals and control flow to have the same semantics as functions, right?
yes,
Yeah.
exactly. Yeah.
Yeah. Yeah. Cool. So before we leave the foundations of Elixir, you're kind of making it seem like all of your early day work was in the parsing and translation world. Is that what makes a project like Elixir hard?
Huh. I think the early days, yeah, yes. I think the answer is yes. Like the early days, I was trying to think what is early days. But if we take the early days, really about like for me, I would say like that was the most intensive period of like language design. Let's say,
Hmm.
it was exactly like figuring out what the language is going to look like, and which features that I want, and how those features map to the Erlang virtual machine. And like,
Right.
how can I implement those features in a way? Because the reason for Elixir to exist is the Erlang virtual machine. So I want the features to be done in a way that is possibly, at least as far as I know, the best way to implement those features, right?
Right.
and i
Yeah.
think and I think generally speaking we're able to achieve that. So I was saying like, about UTF-8, like today Erlang So Elixir had since very early on, like I can like uppercase my name and it will uppercase the accent in my name correctly. It's going to change the with the accent. Like it does a bunch of Unicode things correctly.
Yeah.
And later on, like Erlang pretty much got our implementation of Unicode and added it to their standard library.
Right.
Like implemented differently because in Elixir we can use metaprogramming. Erlang they do it differently, but the idea is the same. So that was the hard at the beginning was look, I want to have these properties, right?
Yeah.
I want to have metaprogramming, and the reason why I want to have metaprogramming and polymorphism because I want to write extensible. Uh, I want to have an extensible programming language, and an extensible programming language is going to be good because people are going to be able to get the programming language and run to solve a bunch of different domains. You know, they're going to use it for web, they're going to use for GPU compilation, they're going to use for data processing. That was the idea,
Yeah.
right? And then figuring this stuff out, it was a lot about the parsing, figuring out the syntax, what it works and what doesn't. But from there, after this initial period, let's say the first 2 years,
Mm.
it was exactly because the language was designed to be extensible. It's like now the huge majority of the work is actually in the language and in the ecosystem. So I spend most of my time actually working on Elixir libraries and frameworks than in Elixir
Ah,
itself
okay. Yeah.
because the language is meant to be extensible. The language is not meant to be a bottleneck. I do not need to ask permission, right? I do not need to ask around. I can go and extend the language, bring it to different places, and explore different ideas with it.
Yeah. Yeah.
And so at some point when the foundation was there, most of the work isn't like I then I was mostly, let's say, I was writing Elixir code. Like most of this on the library, it's implemented in Elixir. You know, most of the tooling is implemented in Elixir. And from that moment on, I am mostly writing Elixir code.
That's a good endorsement because, I mean, if your motivation is to write the language that you want to use and you moved relatively quickly to actually using it rather than tinkering around with the project, you know, you can so easily go down a rabbit hole of language design, but you sounds like you fairly quickly popped back up to the point where it's your day-to-day tool.
Yeah, and there are things also like there are some people I remember, you know, in the early days when trying to promote a programming language, there are like many pointless discussions, and there is one where somebody was saying like somebody was saying like I could push this further. Like I could say, look, I could write all of Elixir in Elixir itself, right? Which we call like I could bootstrap the language
Yeah.
and but to me Elixir is not bootstrap, and then some people would say, well, I don't think any, like some people would say, I don't think a programming language that is not bootstrapped is worth using, right? Because
Yeah.
and then I'm like, well, we did like I don't know the proportion, but it's probably like 95% of the Elixir repository is Elixir files, right? The
Okay.
rest is like shell files, Erlang files, and so on. So we could have pushed it forward, but for us, it's like, look, you know, I want the language to be extensible. Those are the things that I need,
Yeah.
and from there, I'm like, okay, I can go now and I can build the rest, and that's perfectly fine for me. We don't have to rewrite the whole everything else in Elixir. I actually enjoy writing Erlang as well, so I keep doing a little bit of that.
Yeah, you don't want to lose the ability to write it when you've got to be able to translate to its source tree, right?
Yeah.
Yeah. Okay, so that leads into the thought that, I mean, you said to me before we recorded this that you think like about 5 years ago, Elixir was basically done,
Yes.
but you're still working on it. So where's the work happening today?
Yeah. So I did a presentation saying exactly like I think Elixir as a programming language is done, and kind of hinting that most of the work now is going to happen in the community, in the ecosystem. And this was already happening when I did this thing. It's like I don't think it would really have caught people by surprise when I announced that, in the sense that it's like that's how things have been doing. Like I feel like since Elixir 1.6, which at this point was probably 7 years ago or something like that, has been quite some time. It was already clear that what we were doing at that moment is that we were, when we were improving Elixir, it's not because of like, oh, we want the direction to go there. Like the direction was we want the language to go to a particular direction. Like the language already was where we want it to be. But now the issues we're running into were like people saying, look, we need a code formatter because they are starting to have more and more teams using Elixir, and we are going to pointless like formatting discussions. We want to have a code formatter. And
Yeah.
people are like, well, we want to just like they would say like we want the Elixir core team to write a guide telling us exactly how to write Elixir code, you know. And then I was like, well, I would rather just automate them, right? Like if everybody's fine with saying, look, we accept somebody telling us what to do. I was like, okay, so let's accept that and have a tool do that for
Yeah,
us.
yeah.
And then people, and I was not convinced at the beginning, but I'm fully convinced now. um, and then people are like, well, we need to deploy the Elixir experience, and we want to improve the deployment experience in Elixir. And then we worked on improving that experience as well. So it has been quite a while that we're like, look, there are things that we want to make that needs to be part of the language, because like we need to define a rule, right? Like, so what is part of the language, right? And what is not part of the language.
Right. Yeah, yeah.
And we define, and we wanted we keep in mind that we want the language to be extensible, right? And the rule that we came up with is that we will only add things to the language if we can um, if we can show that the only way for that feature or to be implemented or to be maximized is by making it part of the language. Like making it part of the language is going to bring like special benefits
Yeah,
for
yeah.
the feature. And Elixir, because again, it's meant to be extensible, there are very few things that fit this rule, right? So, like for example, we don't have a JSON library in Elixir because I can just add a JSON package, and it's not, and it's the same. Like me adding a line that brings a package and me using the package from Elixir, it's going to be the same. Like the user experience is going to be 100% the same. The difference is one line of code that I add for the
Yeah.
dependency, and that's how we have approached most things. But for a thing like a formatter, it makes sense for the language to say that's how it should work, right? Because if the goal is to have like a consensus, a unique view, like everybody formats code this way, coming
Yeah,
from
yeah.
the language is good. And then the other things that we add are things that exist in Erlang, and it may make sense for us to expose in Elixir because it already exists in Erlang. So it's already there. The hard work is done. So does it make sense for us to expose it in Elixir? And most things we say it doesn't make sense. You can just use the Erlang version directly.
Right.
But some other things it makes sense. So when talking about deployment, Erlang already has this feature called releases, which it gets your application, the runtime, everything, puts everything into a single directory that you can ship to production. You're like, well, Erlang already has that, so let's build on top of that and provide the same experience. I was talking about JSON. Erlang is actually got JSON a month ago, right? And now we are probably going to expose that in Elixir using protocols. So now we are getting JSON, but it's the motivation is not the motivation is simply because, well, now Erlang has it, so it makes sense for us to have it. And the reason why Erlang has it is because one of the protocols used for telecommunication, because Erlang has the root in telecommunication,
Yeah.
they added JSON encoding in the coding, like a very old standard. I think
Right.
it's ASN. They added JSON support, and Erlang's like, well, we need JSON support because I don't know, 5G or 6G somewhere is using JSON in there,
Yeah,
and now
yeah.
it's getting to Erlang, and then we're like, okay, now we're going to have it. But we were able to define like the rules of like what should be part of the language. And then we're like, well, we really tackled most problems that we were supposed to tackle, and it makes sense to be part of the language. So the language, it's close to done, and most of the work should be in the ecosystem. And that was like 5 years ago,
Mm.
and I was 100%. Sorry, and I was 50% right and 50% wrong. Uh, and I was right because I feel like most of the exciting things that have happened in the community with Elixir happen in the community. Like the whole machine learning effort, Elixir compiling to the GPU, live view, we have like audio and video streaming. There are so many things happening, and those are all happening in the community. We are not changing the language to make it happen. This is all work happening around Elixir, and that's fantastic.
Yeah.
And but the reason why I got it 50% wrong is because right, like maybe a year and a half after I said that, so I have like, so one of the things that people always told me, not always told me, but as we solve like those problems with Elixir, when
Mm.
you would ask somebody like, hey, what needs to improve in Elixir, a lot of people would say we need typing, right? And like really majority of people, so and majority in the sense of like, if I would go to an Elixir event
Yeah.
and I would ask who wants Elixir to have more type. I did not say like specifically static type system, but like I want Elixir to go more towards the direction of types and explore something in that direction and have better tools for
Right.
developers. Like really, like the more than 50% of the room would have their hands up, right?
That
So I
surprises me because it's like one of those big dividing lines that you decide. A lot of people decide which side of that line they're on by the time they've chosen the language.
Right, right.
Yeah.
And I think, yeah, that's a very good point. And I think there are a couple things that make, and okay, I have not thought about that. And I think one reason why I would speculate on that, why it's so big for Elixir, it's two reasons, because I like to say that Elixir code is already assertive. So as I was saying, like we do not have like objects where I'm calling to string. Like we do have that as protocols, but protocols, they are like explicitly defined. It's like an explicit contract. And when we have like the other polymorphism, like the to JSON with multiple clauses, you know the type of the things that you are receiving. You're explicitly saying, look, I'm going to have a user, I'm going to have a customer. So we don't have types, we don't have static typing, but we are matching on the types all the time.
So the
So it's
concept of
not,
types is very much there. It's the checking that isn't
yes,
happening. Yeah.
exactly. So, and we have so like, so the code is so assertive that the tool that I was mentioning, like Dialyzer, we have a tool called Dialyzer, and it
Mm.
stands for discrepancy analyzer. The way that it works is that it looks for your code and tries to find things that it can prove that can fail, right? So it's, if this tool finds, and this is just looking at the code, it doesn't use annotations, it just looks at your code and say like, oh, from looking at this code I can find, like, because we are putting the types everywhere, our code is assertive, we can actually have tools that look at the code and say like, huh, I can see here that this cannot possibly be true, so I'm going to emit a warning, right?
Right.
While type systems, they're like, well, this may not be true, right? Like, so one is like, the type is like, oh, this may not be true, so I cannot prove it, so I'm going to emit a warning. And this two is like, look, I can prove that there is 100% an error, and that's when this tool emits the warning.
Right. Yeah. Yeah.
So we have this tool, but this tool has some issues. So Dialyzer, it has some issues. So one is that the error messages, they are really hard to understand. The error messages, they are not precise, and it's a separate tool that you need to run, and it takes a while to run, right? So I like to say that I think that if we got this tool, we made it part of the compiler, made it fast and with good error messages, I think like the my gut feeling is that the majority of the community would be happy with that, right?
Right.
So
Yeah.
I think like this situation where a lot of people want it is exactly because the types are everywhere, and there is a tool that when we look at this tool, we can say things could be better. Like we
Right.
could
Yeah. Yeah.
improve this tool. We could like it like it's like it's like we are circling around the swimming pool and not jumping, right? So I feel like
Yeah.
that's kind of where we were. And then two master students in Uruguay, they sent me a paper because they were exploring gradual typing for Elixir. So I was interested in
Oh.
typing, but I did not know how to move forward. So I got this paper from those master students, and I was like, "Oh, this is really exciting!" And I was like, "Should we try to find a way for us like to work together, like and bring this forward?"
Yeah. Yeah.
And and then they were like, "Nope, we are done with university. We don't want to. It's nothing about you. We're just done with
Yeah.
university."
They don't want to become
Um,
unpaid, barely paid postgrads working for you.
yes. So they're like, "We're done." But then, like, when I went through this paper, most of the references came to the work of Giuseppe Castanha, which is a very known research in the era of static typing.
Mhm.
And so there was a lot of links to his work. And the thing is that when I did the announcement that Elixir is done, I actually tried to implement a type system
Okay.
and for Elixir. And the hard thing about implementing a type system for an existing language, it's because type systems, they inherently they constrain the type of code that you can write. You can write code that you think, look, this feels valid, but the type system is like, I cannot prove it. I'm not going to type check it. You cannot run it,
Yeah.
right? But when you have an existing language with all the semantics already in place, you do not have this option, right? The semantics are in place. So you have to find a type system that suits the language. And if the type system is all the time saying, oh, I can't do that, right? You're either going to end up with a type system that is not really doing a good job, or you have to end up restricting the language and say, oh, you can no longer do that when you are using types. And
Yeah. Yeah.
then
Yeah.
if you do that, if you restrict the language, is it still the same language, right? It's like if I cannot use all the features that exist in Elixir, like what is the percentage, like which features, what is the percentage of things that I can do until I have to say, this is no longer Elixir. This is something else. Like this is a subset of it.
Yeah, yeah. It's that discrepancy between there are rules to the language, and then there's the language that describes those rules, which is the type system. And if there's a like, if you start with the language that expresses the rules, you end up with a language that is restricted to conform to that type system.
Yep.
If you start with a language that just organically evolves its rules, is your rule writing system going to be expressive enough to describe
Yes.
what is?
Yes.
Yeah.
And so when I did this prototype of a type system, and I was like completely fresh to this. I was like, and I talked to some people, to some type system research at the time, and then and I found this thing called intersection types at the time, right? And then I was like, look, I did some things, and not only the type system there, it was it was very restrictive, would have to restrict a lot of things. But if I wanted to have something like type inference, for example, it would be like very expensive. I was like, I built a prototype, and then I went to talk to John Hughes. I showed him his prototype. Like, look, I implemented this, and it's kind of working. But and I implemented intersection types, which he was familiar with. And then I was like, it's kind of working, but it's super slow. And then he's like, yes, intersection types are known to be very slow for inference. And then I
Oh.
was like, I've read so many papers, and I don't remember a single paper mentioning that. Um, and but anyway, we're like, look, so we did this whole thing. There was Eric from the Elixir team as well investigating those things, and we were running into issues. And then so I got this paper for the gradual typing. And then I read the references, right? And then it was Giuseppe Castagna in the references. I was like, okay, let me read some of those papers, let me learn more. And then it was hilarious because I started reading the paper, and the paper was like, look, in this paper we are going to show how to solve problem X, Y, and Z. And I remember exactly that X, Y, and Z was one of the problems that I had when trying to implement a type system. So he described the problem like perfectly. And then I got so excited. I was like, all right, like this is it, right? We got this. And then the paper is like, well, so it introduced the problem, right? And then the paper is like, well, we can formalize this problem as with these mathematical properties. And then it goes to mathematics. It designed the solution in the mathematical world. It proved everything is correct. And then it's like, here, we show it works. And it never went back. It never went back like, hey, here's how you implement this. This is how you're going to look. It's going to look in practice.
Yeah.
Right. So I sent an email to Beppe, to Giuseppe, right? And telling exactly this story, he had like a good sense of humor about it. And he's like, yes, it's like, like when we write those papers to publish at conferences, that's what they're interested in. They're not interested in the implementation.
Yeah.
But I do have a paper talking about the implementation. And we started talking about, like, oh, maybe we should find, somebody to work on this. And then we got a PhD student, Guillaume Duboc, to research, like, can we actually implement a type system for Elixir, and what we can express and what we cannot express, what are the trade-offs. And we published a paper actually going through all those things. Like, look, we've mapped a huge part of the language, because that was the biggest challenge. How can I map a huge part of the language to a type system? We were able to do that in parts where the theory was not there, like Guillaume and Beppe, they wrote like new theory. There's like new type system theory
cool, yeah.
that exists because we want to have a type system for Elixir, right?
Yeah.
And that's the 50% that I got wrong, because now I've possibly, compared to the last like 5 years, now is when I'm working the most on Elixir, because we are implementing a type system for Elixir. And the Elixir release from 3 weeks ago was the first Elixir release to have the type system features.
Oh.
Yeah. And we are I say joking, we say that there are a lot of things that we can talk about the type system. One is that it's a gradual type system, because it needs to interface the static world with the dynamic world, but it's not gradual like TypeScript. Because when I say a gradual type system, most people think about TypeScript. It's actually quite different. But it's a gradual type system. But I say that we are implementing it gradually as part of the language. So it's like a gradual type system.
Right.
And I said this as a joke, but it caused a lot of confusion. So I'm not supposed to talk about it anymore, but here I am talking about it. But the goal is exactly that. So again, like going back to Elixir code being assertive, we can actually get a lot of type information from the code that exists today. So the first 2 or 3 releases of the type system, we are just looking at the code you already wrote, gathering type information from it, and doing type checking. So what it means is that we are going to run static analyzer in our code. You don't have to change a single line. You don't have to add type annotations. Don't have to do anything. And we are going to try to find bugs in your code for you for free. Right? And the idea is that if this works, then maybe we can think about introducing type annotations. But the idea is that we want to try the type system, to implement it, see the performance impact in large code bases. We want to work on the error messages and make sure like that the experience, this initial experience that we are giving to users, that it is a really good experience. And then if it works, and then we will like gradually introduce more features, type annotations, and so on to developers. So it's a lot of work. We are going towards the direction of being a statically typed programming language, because if you have a gradual type system and you don't use a dynamic type anywhere, it is a statically typed programming language. But it's still a few years of work.
Right. Yeah, it sounds. But would you say you've already reached? I mean, if your goal was to be faster and more intelligent than dialyzer. Do you think you've reached that milestone?
So yes, we okay. So the answer is no. Not right now. We are not there yet. So
Yeah.
when we released this new version, people were like, "Oh, Elixir actually found bugs in my code." Okay, and 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 it's good. We are starting to find bugs in people code bases without like dialyzer would, right? So that's good. But and I think we can do part of what dialyzer does, but we cannot do everything that dialyzer does. So I'm going to explain exactly what I mean.
Okay.
So the goal of dialyzer is it's going to say, look, if it's not a type system, it's like if I can prove with 100%, if I'm 100% sure that there is a bug in here, I'm going to emit a warning. So they say that dialyzer is never wrong. If dialyzer has a warning, it's because there's something wrong
Right.
with the code, right? As we said, a type system is not like that, right? A type system is going to say, look, I think there's something fishy going wrong here, right? And or I cannot prove this is correct. Maybe it is. Maybe it's going to be fine at runtime,
I
but
don't
I
have enough
cannot
evidence
prove.
to say this will work.
Yeah,
Yeah.
so that's what we do. We're actually working on a type system, which means that we will not be able to catch all the bugs that dialyzer catch. Okay.
Right.
But it means that if we add type annotations and you have static types, we are going to give you the guarantee that we can now prove that the dat code is free of some typing violations, which is not something that dialyzer can prove. Dialyzer can prove that there is a type violation there. Dialyzer cannot prove the code is free of typing violations,
Right.
right?
Yeah.
While the type system can say, look, this code is free of type violations. So so we can actually, so the way I like to say this is that it's like we got parts of dialyzer. We cannot do everything that dialyzer does, but we can get a reasonable amount of what dialyzer does and embed that into a type system. So it is at some point I can upgrade that to actually be a type system and get the benefits of a type system. And the way it works is actually very interesting, or at least I find very
Yeah. Yeah.
interesting. So, so one of the things that we usually have in most dynamic programming languages is that we have unions, right? We say, look, oh, this code can accept an integer or a string.
Yeah.
And the way you handle this is that you can have, like in JavaScript, you can do type off to check for something in particular. You can check if a method exists, but you can pass unions around, right?
Yeah.
And in a type system, the way it works is that if I have a union, the type system, if I say, look, this thing can receive an integer or a string, you have to write your code in a way that so imagine that you have a function that says it returns integer or a string.
Mm.
The caller of that function needs to handle both return types. Needs to handle both return type. I need to say, look, if I got an integer back, I'm going to do it like this. If I got a
Mm-hmm.
string back, I have to do it like this. So the unions, I have to deal with both sides of the union.
Yeah.
Okay. And even if at runtime, even if I like, look, for the argument that I'm giving, it's that thing is never going to return a string. You are 100% sure, right?
Yeah.
You have to say, look, I'm getting a string. I may get a string here. You can even make the thing raise and blow up. Like I was not expecting to reach here, but you have
Yeah.
to handle those things. You are
Yeah.
required to handle that. The way that gradual typing works in Elixir type system is that dynamic. So we have a dynamic type, right? And usually the way that dynamic type work in gradually typed languages is that it's a wild card. It's a joker. It's a way of saying, look, this thing can be anything, right? It's dynamic. I don't know what it is. It can be anything. So in many cases, it is the top type. It can be anything. Anything is dynamic, right? The way that dynamic works in Elixir, the type system, is that dynamic is actually a range. Dynamic is not like the top type. Dynamic is a range. So I can say if I have an integer or a string, you said it has to handle both. But if I put dynamic on this union, it says, look, you don't have to handle both. You
Mm.
have to handle at least one of them.
Okay.
Okay. So my code, if I put dynamic around, my code is going to be like, look, if I deal with integer, it's going to be fine. If I deal with string, it's going to be fine. If I deal with both, it's going to be fine. But if I don't deal with any of them, then I'm going to emit an error because
Right.
I know it's meant to be one of those two, right?
Yeah.
So if it's not one of those two, I'm 100% sure that it is an error. And that's exactly how the Elixir works. What the
Yeah.
Elixir does, like, you're not handling those two possible things, right? So this was very exciting when we when we realized that, like, wait, what, like we can actually do this kind of things,
Right.
because
Yeah.
exactly what I said, like, so if you want to have static, so if you want to have like the static typing code without dynamic, it's going to work like a type system. But if we want to do things like inference, where I don't want to bother the user and say like, oh, there may be a bug here that I cannot prove, I can have the dynamic going around, and that does not mean, oh, I'm giving up on everything. It means that I will still try to find some bugs if
Yeah.
I can prove that the bug is there. So I find like this very exciting
Yeah.
because, though, like, I mean, I don't want to sound like, oh, but like this, like, there's nobody exploring this. Like, we are the only ones that are exploring this right now, which can be really great, right? Because it's like maybe we found something really great that is going to perfectly match Elixir semantics, right? And it's going
Yeah.
to be
Yeah.
very exciting.
Might
But
change
it
the
can
future of
also,
other systems.
yeah, but
Yeah.
it can also be a disaster, right? It's like, oh, like we think that we have something great, and then like 3 years from now, it's like, like, it's we reached the dead end. We were the only ones exploring this road, so there's nobody we can ask help for, right?
Yeah.
Because we are the only ones here. But I think it's exciting in like thinking about these problems and how we are going to communicate this with the developer, and trying to get the right trade-offs in place, right? There are a lot of
Yeah.
decisions to make here, but I think it's exciting.
Yeah. 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 You're kind of going from mathematical typing to police typing, where you don't have proof, but you gather evidence as you go.
Yeah, and like the interesting thing about this, so the type system that we are doing, we are talking about mathematics,
Yeah.
and the type system that we are doing is it's called set theoretic types.
Okay.
And what I really like about them, it's because everything is done with set operations, everything. So in particular, so like TypeScript, it has like unions, intersections, and negations. Like TypeScript has those things,
Mm.
right? And our type system has something like that as well. Other programming languages like Racket, Typed Racket, have like union, intersection, negation as well. But the way that our type system is implemented differently, because it uses something called semantic subtyping. And the idea is exactly like the whole type system, it's implemented on top of these operations. So if I want to check, like, for example, if I want to check if two types are compatible, like, look, like I'm calling a function,
Yeah.
like, does this function accept what I'm expecting? The way I do this is that I represent types as sets. I get the intersection of those sets. If the intersection is empty, then it means that type checking is not going to work.
Right. Yeah. Yeah.
Those sets, they have nothing common. And I find like this really, I like this because I feel it's more straightforward for us to implement and discuss the ideas, because everything is about intersections, union, and negation.
Yeah. Yeah. Yeah.
Um,
A simple theoretical model that obviously translates into code.
yes,
Yeah. Yeah.
there is something that is very complex, which is that I have to represent I have to represent all the Elixir types in this set, and define it. It needs to be like mathematically proven, like that. Like when I do the union or the intersection between those things, that like needs to exhibit like the correct mathematical properties,
Mm.
right? But that thing, once I implement that data structure, right? So that's where the mathematical is, like it's implementing that data structure.
Yeah.
Once I implement that data structure, the semantics, right? It's obvious semantics that we can all reason about. It's union, intersection, and negation, which means like when so like Beppe and Guillaume, they are the one working on the data structure.
Yeah.
So they kind of like give the data structure to me, and then now
Right.
I can go and start using that in the Elixir compiler. And then I'm like, I'm just asking like, is this an intersection or not? Like it's really straightforward for me to use it. And that's another part that makes it exciting. And it's exciting like I don't know, I don't know how to explain this, right? Like, but the dynamic thing that I was talking about is also defined within that data structure with all the mathematical properties that you expect from it. And I find it's really fascinating. I cannot understand how it all works and proves, but it's like if you have like if you get any programming language, get a programming language that has like a hash dictionary or a
Yeah.
map, like internally, the representation of what that thing is doing in memory, it creates buckets, right? It
Yeah. Red
uses
black
bitwise
trees and
operations. Yeah, there are so
yeah.
many things happening there. But when we use, we don't care, right? Like the
Yeah.
complexity is abstracted for us. And here it's exactly like that. And it makes me happy because if I had to do like I would be like, if I had to do like a PhD to understand the mathematics, to do all those things, right?
Yeah.
Then it would slow everything down.
But you've got this surface level tool that you can just use as a programmer. It's funny how you've gone from being a language designer to someone who thinks the job is done to someone using a different library to become a language designer again.
Yeah.
Yeah. And you seem fired up about it. Really fired
Yeah.
up. Yeah.
Yeah. I mean, I enjoy those things, generally speaking. Like for me, it's like it's because I'm learning a lot, and I think like that's what makes me excited about those things. It's
Yeah.
like in a way, like I always had like some concerns, like like, well, maybe like when I get older, like 12 years, right, I'll be
Yeah.
like, oh, like get fed up with this. But I kind of like, it kind of has the opposite effect, because it's like now whenever I learn something, I am like, oh, it has been there for 12 years and I did not know this. Like the opposite effect. Instead of being like jaded, it's like, I'm like, oh, it has been there since like forever.
Just
And
waiting to be discovered.
yes, right.
Yeah.
And so there is a nice project. So there's a project called Flame from Chris McCord, the creator of the Phoenix Web Framework.
Right.
And what it does is that like the project, when he released it, was like 200, 300 lines of code, something like that. Maybe a bit more. Let's say less than 1,000, which is not a lot with docs, right? And what it does is that it's auto scaling on demand. You can easily, in your Elixir code, start a new node, send code to that new node to execute it, and it
Mm.
sends the result back. And the reason why this is very easy to implement in the Erlang virtual machine is because Erlang has always supported distributed execution.
Yeah.
So distributed execution is part of Erlang, is part of Elixir, right? And then this library is like, well, I can use something like Firecracker, which is something that can start nodes and machines really quick, right? So you can use something like that to start a node really quick, have that thing do the work for you. Like if you want to do something that is expensive and you don't want to do in your main machine, so we spawn a new machine really quickly, you execute something there, right? And it gives you the response that the machine shut down. And you can have a pool, and then you can auto scale easily, right? And this is
Yeah.
great because it gives you the level of where you want to auto scale your code, right? Usually it's like, oh, you want auto scale, then you have to do a Lambda, like you can use Amazon Lambda, but then you have to talk to an API. So you have to serialize your request, put it on a queue, or send it to Lambda. Lambda gets the result, puts on S3, you read back. Like there's so much
Yeah.
that you want to do. And here's like, look, I'm going to start a node. I'm going to send the data structures that I have in memory, because Erlang can do that. Everything, all the Erlang data structures are serializable. I get them back. I'm happy. And I think he released this last year. And then we were talking, and I was like, look, we could actually have released this 8 years ago. Like
Yeah.
there is there is nothing that we are doing here that did not exist for 8 years, a decade already. It has always been here. And
Yeah.
then we're like, this is it's like, for me, it's like, it's fascinating. And then it keeps like this kind of like, the spirit is like, what else do I have to discover? Like, what are the hidden things that are waiting for us?
Yeah. This is why I think you can have a whole career in programming that never gets old, because there's always more to discover. It's
Yeah.
great if that's happening. We might have to get him on to discuss that system. That sounds cool.
Yeah, he would definitely love to join, and there are a lot of things that he would be able to share about Phoenix and Flame in general.
Cool. Okay, so one final topic of conversation before I let you go back to all the things you have to work on and discover. Because we've talked about your journey from 2012 to today, but what's Elixir's current state of the journey? Who is Elixir for today? What status is it at?
So, like, the obvious person Elixir is for web developers. I think that's where most people are. And Elixir, the promise of Elixir is that. So today, I think I'm going to use my usual pitch, which is, the promise of Elixir is operational simplicity. So today, like, most people who are building web applications, like, most of them, they are like drawing in complexity, because you start with your web application, and then you add a database. You have to add a database, and then you want to do like some background processing. You need to bring a library, or maybe another system like RabbitMQ, SQS,
Yeah.
to do that thing for you. And then you want to do some real-time messaging, so you bring another service, right? Or maybe people, they even, like, sometimes they want to bring authentication, and then they have to pay for an external provider to give authentication to users.
Yeah.
And, like, every time you are doing this, you are bringing operational complexity, and we are also, like, keeping everything away from us, right? Like, now I have those 3 services. So if I'm going to run those are things I have to deploy and manage in production.
Yeah.
And if I want to run the tests, I either need to have like a mock version of RabbitMQ or SQS, right? Or I need, and then if there is a bug, you're going to find out in production, not during testing.
Yeah.
And so there's like so many complexity. We are kind of like constantly um, relying on external things. We are bringing those external dependencies. We are giving up control, and that brings complexity to the development, because now I need to use those 3 different things, 4 different services to get anything up and running. Like, every project starts with a Docker Compose that is bringing 4 or 5 things up,
Yeah.
right, to do anything. And so there is a lot of complexity in there. And I like to say that I think I think programmers, they are the only people who take the word dependency lightly. Like, the only ones. Like, everywhere else in life is like, somebody says, "Hey, do you want this dependency? Do you want this thing that if something goes wrong, you are responsible for it
Yeah.
and you have to take care of it?" And then programmers like, "Yes, give me 100 of those, right? Like,
Yeah.
just right here." So I think that's where a lot of people are. That's describes like the day to day of many projects. And the goal with Elixir is that you need Elixir and a database, and that's it, right? You're not sure. Are you going to use Elixir libraries? Yes, you're using that, but with Elixir and Phoenix for a web developer, that's what you need. Uh, Distributed pub sub. So if you want to do anything real time, oh, this user, your friend joined. It's part of the box. Presence. You want to know who is connected in a cluster right now. Oh, your friend joined, your friend is online, send a message, comes out of the box. There is literally like no other framework that comes with those things out of the box. It comes with internationalization out of the box. It comes with a dashboard, like a monitoring dashboard, because the Erlang virtual machine is excellent for this. So there is a dashboard where you can see all the code running in your system, where things are in memory, how much memory is being used. It's all there. Like, there is so much packed out of the box. And with things like there's a project called Live View, which allows you to
Oh
create
yeah.
interactive real-time web applications, controlling them from the server. And if you go to my company blog like dashbit.co, or you go to the Phoenix Framework website, there are a lot of articles about those, on how that solution works. Like, everything's out of the box. So ultimately, you get control back of anything. It's all part of your experience, right? And when you're
Yeah.
going to run into production, it's going to scale to multiple cores. You can scale horizontally as well, because distribution just works. So it offers so much, and it reduces so much complexity overall. And that's the pitch. I think, like, and this is not like, we're not saying like, oh, you're getting all those things, but now you have to write like low level code or anything. No, Elixir is like, it's a high level expressive language, as we have been talking about. So I think, like, for the web, it's like, it's a really, like, really sweet spot in giving you everything that you need, but keeping you productive and being able to ship what you want. So for that's the easiest pitch. It's like, that's what attract Elixir developers, most Elixir developers nowadays, most developers to Elixir. But I've always been like, we are talking about the language being extensible. It's because I never wanted Elixir to be, I knew Elixir was going to be good for web, because I came from Ruby. I worked on Rails for several years. I knew, like, people who were following me, they had that background. So I knew it was going to be good for web, but I was like very careful to like, I don't want Elixir to be a web only language. I don't want this to be tailored for web. I want it to be like a general purpose programming language.
Right.
And then with time, we saw many things happening in the Elixir community. So we have Nerves, which is about building high-ended embedded software as well. So there is a whole framework for doing those kind of stuff.
Okay.
There is audio and video streaming, and building like data-driven pipelines as well. There are libraries for doing all those, for tackling all those sort of problems. And the most recent one that we kind of talked here and there today was the numerical Elixir effort, which is um, look, we have Elixir. We can actually implement machine learning, deep learning neural networks in Elixir, get that compiled to the GPU, right, and run that. And then we have Livebook, which, for those who have used Jupyter notebooks, it's kind of like the Jupyter
Oh, okay,
notebooks
yeah.
version, but tailored to Elixir and leveraging Elixir strengths. So there is a lot that we have been working on this area, but it's like, it's a new area, right? Like, if you
Yeah.
there are things that I feel like we offer, like unique abilities that you don't find anywhere. So I have a presentation called Elixir and Livebook, where web concurrency and AI meet. If you put Livebook, Elixir, concurrency, AI, that's probably going to show up.
I'll find a link and put it in the show notes.
Yeah, and what I do in this talk is that I introduce Livebook. Like, the first 20 minutes, I introduce Livebook, our coding notebook platform.
Yeah.
And in the next 20 minutes, I live code a web application that is doing machine learning distributed in a cluster. In 20 minutes, I live code that.
Oh, that's fun.
Yes, and it's like, and this is not like, oh, this works because I am bringing a separate solution here that is going to serve the machine learning model for me. No, like, it works because I have everything, like, I don't have external dependencies. It's everything running in Elixir. I'm using Elixir to talk to other machines that are doing machine learning, and it's all there, right? Which I think goes exactly to what I was saying about Phoenix. There is so much we can do, and it's not even most of it. The credit is not Elixir credit. It's really the airline credit. It's the platform that exists for like almost 4 decades, and we keep discovering new things to do with it. And so that's a new exciting area.
Yeah.
But it's like, if you want to, if you like that, go give it a try, but beware that is like, we are still in the process, right? We are catching up to, I think, I don't know, 2-3 decades of Python still. So it's a lot of catching up. But I think it shows, there are parts where it already shows like where Elixir and this platform can be so great and so unique.
Yeah, yeah. It's funny. I've never known any platform to attract as much love as the Beam does. And putting a friendly user space language on top of that is full of potential. You've done your job. You've made me want to go and watch that video and try it out for myself. So maybe we should wrap up there. Thank you very much for taking me through both the compiler and the language space today.
Thank you for having me. I had tons of fun. I really enjoy talking about this stuff, so I appreciate the opportunity.
It shows. Thanks for joining me. Thank you, José. I have to say, that was a longer episode than usual, and I still feel we could have talked for twice that time. So if you're feeling similar and you're left wanting more, I'm going to put a link in the show notes to our episode on Gleam, which will give you at least another hour's worth of typed programming on the Beam platform. And I'll put a link to everything else we discussed in the episode in the show notes, as usual. On the subject of podcast length, I'm going to have to run a poll, I think. How long is the right episode length? Should it be an hour? Longer? Shorter? I've always gone with the rule that it should be as long as the conversation is and no longer than that. But if you have thoughts, please share them. While you're sharing, if you enjoyed this episode, please leave a like, maybe share it with a friend if you think they'd find it interesting. And if your only feedback is please carry on, maybe consider supporting Developer Voices on Patreon, which we recently opened. You'll find a link to that in the show notes. Thank you very much to everyone who's signed up so far. Thanks to everyone who's persuaded their marketing department to sign up too. That helps. We'll be back next week with more, so make sure you're subscribed for that. And until next week, I've been your host, Chris Jenkins. This has been Developer Voices with José Valim. Thanks for listening.